So now that you've learned about how to calculate concentration, we're going to incorporate concentration into solving stoichiometry problems. So if you look at this problem, I tell you, you have 100 mils of a 0.400 molar solution of silver nitrate, and I want to know how many grams of silver chromate could precipitate in this reaction. So you've got silver nitrate reacting with potassium chromate. So before I even get started, I've got to write out this reaction. So I've got silver nitrate reacting with potassium chromate, and it's going to produce, remember this is a double replacement reaction, so silver will go with chromate and potassium with nitrate. So it's going to be silver chromate and potassium nitrate. Then I've got a balance, I'm going to put a 2 and a 2. Now I can actually solve this problem. Well, I know the concentration and the volume of silver nitrate, which means I can figure out the moles of silver nitrate. Once I know the moles of silver nitrate, I can get back into moles of silver chromate by using my mole-to-mole ratio, by using stoichiometry. Once I know my moles of silver chromate, then I can get into grams of silver chromate. So I'm going to start off. I've got my volume, but remember, since your volume is in milliliters, I've got to get it into liters in order to use it with molarity. So I'm going to put 0.1000 liters. Okay, I'm going to multiply. I'm going to put liters on bottom, and I'm going to put moles up top. Now, that relationship, moles over liters, that is molarity. So I'm going to put 0.4 on top and 1 on bottom. That's my concentration. So that's the only new thing in this entire problem, is that step of getting into moles. Now that I'm in moles, I can get into moles of silver chromate. So I'm going to put moles of silver nitrate on bottom, moles of silver chromate up top. It's 1 to 2. Then I can get into grams of silver chromate. So I'm going to put moles of silver chromate on bottom and grams up top. Then I'm going to put the molar mass and 1 on bottom. All right, so now I just do the math, and the answer I get is 6.63. So the only new thing here is the fact that you can convert from liters into moles by using your concentration.
So in the previous problem, I went from concentration of a solution with a specific volume, and I was able to convert into the mass of a totally different compound using stoichiometry. Well, there are a number of different applications of using molarity or concentration in stoichiometry. So let's look at some other examples. So these examples actually come from your textbook. So if you also want to look at their description, please feel free to do so. So this tells me zinc reacts with hydrogen chloride or hydrochloric acid to produce hydrogen gas and zinc chloride. So there's my reaction, and it is balanced. And it says how many liters of a 1.50 molar hydrochloric acid solution completely reacts with 5.32 grams of zinc. Okay, so I know I'm going to want to get into liters of HCl, which means I'm going to use this conversion factor, my molarity, at the very end. So what I'm going to start with is I'm going to start with 5.32 grams of zinc. So I'm going to go from grams of zinc. I want to eventually, since I want to get into liters of hydrochloric acid, I want to get into moles of hydrochloric acid. Well, in order to get into moles of hydrochloric acid, I need to get into moles of zinc. So in order to do that, what I'm going to do is I'm going to put the molar mass of zinc on bottom. Okay, I'm going to put 1 in front of moles. I'm going to put the molar mass of zinc on bottom, which is 65.41. Okay. I'm now in moles, and I'm going to write this just so it's clear. I'm in moles of zinc. Now I want to get into moles of hydrochloric acid. So I'm going to put moles of zinc on bottom. I'm going to put moles of HCl up top. So I got to look at my mole-to-mole ratio here. I'm going to look right up here. I've got 2 moles of hydrochloric acid for every 1 mole of zinc. So I'm going to put a 2 and a 1. Now I'm in moles of HCl. Let's look at this problem again. It says how many liters? So I want to get into liters, so I'm going to put liters on top because that's what I'm trying to get into. Notice my grams cancel, my moles of zinc cancel. I need to cancel my moles of hydrochloric acid. So now, since I have moles per liter, just like in the previous problem, moles per liter is molar. However, remember, when I say 1.50 molar, what I'm saying is I have 1.50 moles of hydrochloric acid for every 1 liter. Okay, so I'm going to put a 1 here, and I'm going to put my 1.50 moles here. And now I simply have to divide by 65.41, multiply by 2, and divide by 1.50. I want to have 3 significant figures, as I can see here, so what that's going to end up equaling is 0.108 liters of hydrochloric acid. Okay, so that's my answer. Let's try another one. It's going to be slightly different, but again, we just got to figure out what I need to get into, and that is what I'm going to be using my concentration for it later on if I'm needing to use concentration, okay? So let's figure it out. It says how many milliliters of a 0.250 molar barium chloride solution are needed, okay? So here is what I'm trying to get into, which means I'm going to use this concentration at the very end because I'm trying to get into milliliters of barium chloride, okay? Are needed to react with, I have this volume and this concentration of sodium sulfate. So what that tells me is that I can actually find out the moles of sodium sulfate so that I can then get into moles of barium chloride. So I'm going to start off, I have my volume of sodium sulfate. So there's my volume, I'm in liters. I'm going to multiply that. I'm going to get into moles of sodium sulfate by using the molarity because I'm going to put liters on bottom, moles up top, that is moles per liter, which is molarity. I'm going to put 0.160 moles on top and 1 on bottom. That's the new idea here. Now I'm going to put that I'm in moles of Na2SO4 just to make that clear. I now want to get into moles of barium chloride. So I'm going to put moles of sodium sulfate on bottom, and I'm going to put moles of barium chloride up top. I'm going to use my mole to mole ratio, which is given to me right here. I am balanced, so I'm good. This is 1 to 1. So I'm going to put 1 to 1. Now, I'm going to get into milliliters, but first I need to get into liters. So I'm going to put moles of barium chloride on the bottom. I'm going to just put moles to save space because we know what I'm in. I'm going to put liters up top. So this again is my concentration. So I'm going to put the 0.250 on bottom because that's 0.250 moles for every 1 liter. In this problem I would have been done because it asked for liters, but now I got to convert to milliliters. So I'm going to put liters on bottom, milliliters up top. For every 1 milliliter, there are 10 to the negative third liters. Okay, so I'm going to do out this 0.0325 times 0.160 divided by 0.250 divided by 10 to the negative third, and what you should end up getting for your final answer, since I want 3 significant figures total, because this says 3 sig figs, 3 sig figs, and 3 sig figs, is 20.8 milliliters of barium chloride. Okay, so all of these problems are super similar. It's just a tiny alteration based on what you are solving for. All right, so using the steps that we did, I'm going to do one more problem. So in this problem, it says acid rain results from the reaction of nitrogen dioxide with water and air. It gives me my reaction here. It says at STP, how many liters of nitrogen gas are required to produce that volume and that concentration of nitric acid? So one thing that needs to be clarified. Notice NO2, it's asking about NO2. NO2 is a gas. So when it is a gas and when it is at STP, and only when it's at STP, we can make the assumption that 1 mole of that gas has a volume of 22.4 liters. Don't let this fact that we had studied in a previous unit confuse you with molarity. When we're talking about molarity, we tend to be talking about aqueous solutions. Okay, so that's why I have molarity for one of them while I'm talking about STP for another, because one's an aqueous solution and one is a gas. So I'm going to be solving for NO2 eventually, so I'm going to start off with my given, which was the 0.275 liters of NO3. I'm going to convert that into moles of HNO3 because I want to be able to get into moles of NO2. So again, moles per liter, since I'm dealing with concentration, it's going to be 0.400 moles for every 1 liter. I'm going to get out of moles of nitric acid, and I'm going to get into moles of NO2. I'm going to use my mole to mole ratio, which is 3 to 2. Now here's the not really new step, but where you just have to be careful. You're used to now using concentration to be able to then get into liters. That's what we've done in previous problems. But since I have a gas and it tells me I'm at STP, what I can say is, all right, 1 mole of NO2 is going to have a volume of 22.4 liters. So that's how this problem is slightly different. Still using stoichiometry, still using concentration, but now going back to the idea that a gas at STP has a volume of 22.4 liters in order to do a slightly different calculation. So for this problem, when I do that, what I get, because I want 3 significant figures, all of the values that are given to me have 3 sig figs, I'm going to have, my final answer will be 3.70 liters of NO2. Okay, so you've got 4 different types of problems that I could ask you about. Go back, rewatch this video to make sure you're clear on all the different alterations that you can make to a problem like this.